All right, welcome back to Weird Math Chemistry Edition. Okay, so this is the quiz that we worked on March 4th, 2025, which was today. It is quiz number 11. So we're going to run through this real quick, work some problems. First thing we're going to talk about is first steps and type of equations to follow. So anytime I get one of these quizzes, especially with these where we know we're going to need pKa or KB, I just go ahead and solve for that first off. So you're going to find pKa1, and that's going to be the negative log of your Ka1, and then you're going to find pKa2, and that is negative log of Ka2, right? And then we're going to solve for pKb. I'm not sure that we will need pKb, but we're going to solve for it anyway. I'm going to pause that now, run those numbers, so this video is not ridiculously long. Okay, so I have got pKa and 1 and pKa2. One important thing to remember with these diprotic or polyprotic acids and bases, so when you have two steps, like this one here, you've got H2Q, and that's going to dissociate to H plus HQ minus, and then HQ minus for dissociates or reacts into H plus and Q2 minus. Your Ka1 value, so if we're solving for this, Ka1 times Kb2 is going to equal Kw, okay? And that is because if we wrote this reaction back in reverse, and I can pause this for a second and do it on another piece of paper, and I will in just a moment. If we write those back in reverse, we have to match out our species and make sure that we have everything that we need to do. So I'm going to just set this to the side, and we're going to write out our original equation is H2Q, and that's going to H plus HQ minus, and then we've got HQ, and that's going to go to H plus Q minus, Q minus 2. So this is Ka1 and Kb, or Ka2, right? But if we're starting with our base here, so if we start with Q minus 2 and we react that with water, what's going to come of that is HQ minus plus OH negative. Okay, and what we're doing and how we're pairing this up is that we look at the full of both equations. So then we're going to take HQ minus, which is our other half. So HQ minus, and we're again going to put that with water, and that is going to give us this right here, H2Q plus, and then so you've got one H that's going over here and one H that's staying, OH minus. And so if you look at your charge balances, you got -2 here, -1 here, and then you've got a minus here. So your charges balance. And so these are, you got your bases here, right? These are your Kb values, and you're going to match those up by looking at your species that go with it. So you've got Q minus 2 and HQ minus, okay? Well, that matches up here with Kb2. So if we're going in reverse, or Ka2, sorry guys, this is going to be Kb 1. And then this one here, because this is our first step in going from full on base back to our acid, so that is Kb1. This one here, you've got HQ minus and H2Q, which is here. That should be a minus. And so this is going to be your Kb2. All right? So that's just one very important thing to remember when you're dealing with polyprotics. Triprotics, it's very similar. You start counting down 1, 2, 3, and then you count in reverse. in going back up. So your Ka1 is going to correspond with your Kb2, and your Ka2 is going to correspond with Kb1. If you have any more questions about this, let me know, and we can go into a little bit further detail on another sheet. But for right now, we're going to leave that as it is. And then we're going to talk about some of these equations, and then I will solve them on a separate video because this is already getting kind of long. Right. So part A, you're looking for the pH of a solution containing NaHQ. Now HQ, if you'll look here, HQ, and sodium is just a spectator, so you can just pretend that that's not there, and that's going to give this a minus charge. HQ minus is our intermediate species, okay? And with the intermediate species, when you've got a solution just of that, remember the intermediates can act as an acid or a base. And so we're going to use the 1/2 pKa1 plus pKa2 to get the pH of this one, right? And we will solve this out in a separate video. Now, part B. What is the pH of a solution containing 0.037 molar of H2Q? This is our acid, right? So we are going to use our Ka1 is going to equal, it's very important to write these reactions out. That way you know exactly what you're solving for. Okay, so H2Q, and that's going to dissociate into H plus HQ minus. And remember with our Ka equation up here, let's see where to go. Right here. Can you guys see that? We are looking for our A minus, which is our conjugate, times our hydroxide ion concentration over this little guy right here, over our acid. So that's what we're going to use to find this. Right? So we are going to put the concentration of our hydrogen ion times our salt over this concentration here. This is going to be x squared over H2Q. And that's how we're going to solve that. And we'll work out that a little bit further in another video. But let's just keep going here. Now, these last two, these are buffer problems. So you're going to use the Henderson-Hasselbalch equation on here. And the important thing to remember is that you have to decide which pK value that you're going to use, because this right here and this right here, these are both Henderson-Hasselbalch equations. So you have to figure out which one you're going to use. All right, so let's look for our common acids, like what we have in common here. So we've got HQ minus, okay, that's our intermediate species. That could be acid or base. In this case, remember our sodium dissociates and does not participate, so that gives us Q minus 2, okay? And if we look back up at our reactions here, for our minus 2 here, we're going to use our pKa2 value. Okay, so our pH is going to equal pK2 plus the log of Q minus 2 over HQ minus. Now another thing that we need to look at on this equation is that we have got to actually put this in moles because we have different volumes. We have 250 mils here of our HQ minus and 200 mils of our Q minus 2. Okay, so we've got to first convert those into moles, and we will do that again in a separate video. Now, our last equation is another Henderson-Hasselbalch equation, and so let's just go ahead and take a look at it. We have got HQ minus, remember sodium doesn't participate, and H2Q, okay? So this is going to be our pK1 plus the log of HA minus over H2A. So we're going to use our pK1 value in this one. All right, and this was Q minus over H2Q. And again, with this one, because we have different volumes, we do have to solve this for moles. And if any of you got this question wrong on the quiz today, that could be where the error lies. If you did not put this into moles, you won't get the correct pH. All right, so I'm going to stop this video now and go ahead and post it, and then we'll solve out the problems in a separate one. Thanks.